Alrighty. In this one, we're going to talk about something called net ionic equations, and this is just ways to represent what's going on in solution during a reaction. And this is a skill that we're gonna learn how to do, and we're gonna be able to use it for all kinds of reactions and stuff. Okay. And so let's just work through a couple of examples, and I'll show you what we're talking about. All right. So let's start off by writing an equation. So this is our sentence. We're gonna say a solution of silver nitrate is added to a solution of sodium chloride and the precipitate of solid silver chloride is formed, leaving behind a solution of sodium nitrate. All right, so let's write this equation. Silver nitrate is AgNO. Don't need parentheses in there. AgNO3. This is in solution. Okay, we're going to add sodium chloride to this in solution. And we're going to make a precipitate that is solid silver chloride. Right, we could use our solubility guidelines to figure out that silver chloride is insoluble, so we should get the solid to happen there. And we're going to get a solution of sodium nitrate left over. Damn it, I keep putting parentheses when I don't need to. NaNO3 aqueous. All right, there's our equation. What we've written here is known as the molecular equation. Okay, this is the equation. This is what, right, we're going to make sure it's balanced, and it's balanced, but what this is showing us the what the formulas are of everything that's doing the reaction. Okay, it's called a molecular equation, but all that means is we're using complete formulas, and it's what we think of when we think of our normal looking chemical equation. Okay, so our goal is going to be we're going to turn this into a net ionic equation. I'm going to show us how to do that. Okay, so here's our equation written more nicely. We want to dissociate this into ions. So when we do this step, everything that's a strong electrolyte is going to dissociate. I should say this strong electrolyte that is aqueous should dissociate into ions. So here we have silver nitrate, which is an ionic compound, and it's aqueous. So we can say, well, this is really silver plus and NO3 minus. We have sodium chloride, which is ionic, and it is also aqueous. So we're going to break that apart. Sodium plus, aqueous, and chloride minus, aqueous. All right. Then we have silver chloride, which is an ionic compound, but it's a solid, so we're going to leave it together. The only thing, that can dissociate here are going to be things that are aqueous, and then only if they're strong electrolytes. So we're going to get into this as we do it. Okay. All right. So silver chloride stay together. Then you have sodium nitrate, which is aqueous, so we can dissociate it. Dissociate it. Come on, dude. Na plus, aqueous, NO3 minus, aqueous. Okay. What we have here is called the complete ionic equation. All of our strong electrolytes are now dissociated into ions, only if they're aqueous, right? So let me give you a little side example here while we're thinking about it. If we had, say, we're doing a reaction and you put in solid sodium iodide, okay, it would still do the reaction, but when you're writing the net ionic equation, because it's a solid, it's not going to dissociate. But if you use sodium iodide and it's aqueous, then this dissociates into Na plus and I minus aqueous. Okay. And we'll see some examples of this as we do stuff. Okay. Anything that's not aqueous and a strong electrolyte will stay together as its whole formula. That's what we did here with our silver chloride. Okay. Once we have our complete ionic equation, we can look at it and look for what are called spectator ions. Okay. A spectator ion shows up on both sides of the equation as the ion itself. So for example, we have a sodium that's aqueous here, and we have a sodium that's aqueous here, right? We have a nitrate that's aqueous on the product side, and we have a nitrate that's aqueous on the reactant side. Okay. The spectator ions have to appear as ions on both sides of the complete ionic equation. Okay, that means they're not participating in the reaction. So if you want to think of it this way, if you put sodium into the equation and you get sodium out of the equation, the sodium's not doing anything during the reaction. Okay, what we can do with that then is we can write right. That means the nitrates are going to cancel out and our sodiums are going to cancel out, and we can write uh, an equation for whatever is left over, and that would tell us silver plus aqueous plus chloride minus aqueous gives us silver chloride solid. Okay, what we've just written is the net ionic equation. The net ionic equation has all the spectators removed, and it shows exactly what's happening with the chemistry. Okay, it also gives us a hint that it doesn't matter what the spectators are, as long as we get silver ions and chloride ions in solution, we'll get silver chloride. So for example, if we were to write silver chlorate, aqueous, reacts with lithium chloride, aqueous, we're still going to get silver chloride. I'm going to show you how to predict products in another video here too. Silver chlorate, lithium chloride, so we're going to have lithium chlorate left over. The spectators have changed, but the net ionic thing is going to be the same. Okay, let's look at another example here. Oh, no, this is another picture. Sorry, I forgot what I was doing. Okay, all right. So this is just a pictorial example of what we did, right? We took a bunch of sodiums and chlorides, mixed them together with silvers and nitrates. We got a silver chloride precipitate on the bottom, and we have sodiums and nitrates left over. So the net ionic equation is the stuff that did the reaction, and the spectators are what's left over. Okay, just gives us an idea of what's going on. Okay, while we're thinking about it, let's go ahead and say what our secret word is. Our secret word for this is biscuit. Okay, so enjoy that. Do with it whatever you need. Okay, let's see. Hopefully this. Okay, here's our other example. Okay, we're gonna take a solution of lithium sulfate and lead 2 nitrate and mix them together. We're gonna get a precipitate of lead 2 sulfate, and we're gonna get a solution of lithium nitrate. Okay, let's write what the net ionic equation for this looks like. Okay, remember, first thing we want to do is to break apart our strong electrolytes that are aqueous. So lead 2 nitrate is an ionic compound that's aqueous. We're going to break it apart. So we get a lead 2 plus. We remember we did this when we talked about naming things too, so we can work our way through this as well. There's 2 here, so we're going to get 2 NO3 minus aqueous. You always want to work with a balanced chemical equation as we do this. Okay. Let's see. We have lithium sulfate that is also aqueous. And so this is a strong electrolyte that's aqueous. We can dissociate it. We have 2 lithiums, 2 Li plus aqueous, and we get a sulfate left over. That is aqueous. Okay. On the other side, we're going to look at this. We've got a lead 2 sulfate, and it is a solid. Because it's a solid, that means it's going to stay together, and we don't dissociate it. So that's going to be PbSO4 solid. And then we have one more thing over here, and that's lithium nitrate. There's 2 lithium nitrates, and they are aqueous. So we're going to get 2 Li plus aqueous and 2 NO3 minus aqueous. Okay. There's our complete ionic equation. If we take our complete ionic equation, let's look for things that are the same on both sides, right? We have 2 lithium that are here, and we have 2 lithium here, so those cancel out. We have 2 nitrate on the right, and we have 2 nitrate on the left, so those also cancel out. Okay, this gives us whatever's left over as a net ionic equation, and that is Pb2 plus, that is aqueous, reacts with a sulfate 2 minus, that is also aqueous, to give us a PbSO4. That is solid. Okay. Remember, we want to keep our phase labels in here and keep everything together as we go. Okay. This is one of those, another one, I say this every time, right? You got to practice, practice, practice. You got to get this under control and be able to do it. Net ionic equations is one of the things that Gen Chem 1 students typically have a problem with. So make sure we know how to do this. Come get help, ask questions, work examples. I'm here to help. Okay. I'll see you in class.